From our last engineering problem video, we learned how to use algebra to set down equations from the equivalent values we had from the problem. We collected the information, we listed them down, and then we learned a very special technique of subtracting one whole expression to another. And in this video, we are going to be looking at another engineering problem on how to use drawing number lines the whole project. So yeah, let's get on with it. Jane and Michael are collaborating on a project. After Michael worked 5 hours, 1/4 of the whole project was completed. Then Jane continued working for 6 more hours and completed 1/2 of the remaining work. If Jane and Michael decided to work together for the uncompleted parts of the project, how long would they take to finish the whole project? So let's review that problem and collect the information we've got. After Michael working 5 hours, 1/4 of the whole project was completed. Then Jane continued working for 6 more hours, completed 1/2 of the remaining work. So that's another key point there. Then Jane continued working for 6 more hours and completed 1/2 of the remaining work. If Jane and Michael decide to work together on the uncompleted parts of the project, how long will they take to finish the project? So how are we going to do this? We know that after Michael worked 5 hours, 1/4 of the whole project was completed. Based on that information we've got, let's draw a number line. So there's my line. And now I'm asking you a question. What is the unit of time we have here? You've got it, hours. And how much segments should we split up this number line into? So now let's think from here. What can this number line represent? It told us that Michael working 5 hours, 1/4 of the whole project was completed. This 1/4 of what? 1/4 of the whole project. And remember, since it's a whole project, we'll give it the name Unit 1. And think of it as one whole. And the denominator of this fraction over here, 1/4, it will give us information that's split up into 4 parts. So there's my 0, and there's my 1. We split it up, that's about the middle. It will split each segment up into halves. That's 1/4 each. So after Michael working 5 hours, 1/4 of the whole project was completed. So after him working for, that'll be Michael. So after Michael working for 5 hours, so after him working for 5 hours, he completed 1/4. I'm shading 1/4 in, and we'll just have an M for short for Michael. So that's what he has right now. And now let's read on. Then Jane continued working for 6 more hours and completed 1/2 of the remaining work. So there's one key point. It's not saying she completed 1/2 of the whole project. She completed 1/2 of the remaining work. The remaining work means 1/2 of the work left over. So we know that she went on working for 6 more hours. But what is the value of 1/2 of the remaining work? Well, let's think here. We already know that Michael worked 1/4 of the whole project. So how much is left over? 1 subtracted by 1/4 is equal to 3/4. So that's this part over here. That's 3/4 of the whole project. And then it's 1/2 of that. Remember, when you see the keyword of, it usually means multiplication. So that would be 1/2 times 3/4. 1/2 times 3/4, we multiply the numerators and the denominators. That would give us 3/8. So if you were actually to mark it, I would say that 3/8 is, well, this is 2/8, and then one more eighth. That would be about here. That doesn't really show anything. So that would be about, let me see. So that would be about over here. I don't know if you can see it or not, but I'll just use this. Okay, so this part will be 3/8. So by now we have 3/8, and it's 6 hours by Jane. So we have this out. What do we need to know before figuring out how long they would take to finish the rest of this? Well, for one thing, we don't know the time. That's what we're trying to find here. But we do know this whole amount over here. We just have to subtract 1/4 and 3/8 from 1 now. So we know the whole, what this empty bar here is. And we also do not know the unit progress rates or work efficiencies of each person. But really, do we not know it? Or is there a way to find that out? Look, over here it already said that after Michael worked 1/4 of the whole project, he had to use 5 hours to do that. So that's our time. So this is how much he completed, and this is how much time. To find the work efficiency, we have to divide 1/4 by 5. So we're going to divide that. That's 1/4 divided by 5 is equal to 1/20. So Michael's unit rate, I'm just going to write Michael unit. You know what? Michael's work efficiency is equal to 1/20 per hour. So looking at what I have done here, pause the video and do the same for Jane using what we have known. What did you get for Jane? It's the same exact thing actually. She works for 6 more hours, and 1/2 of the remaining work, that's really 3/8. We do that, that would be 3/8 divided by, let's see here, 6 is equal to 1/16. So that means that Jane work efficiency, EFF, is equal to 1/16 of the whole project per hour. So now we've got that figured out, and the rest should be probably really easy. We know that this part, well, let's find out that part. That part would be 1 minus the sum of 1/4 plus 3/8. And if we simplify, that would give us 1 minus 5/8 or equal to 3/8. So that's another 3/8. And we know their work efficiency. So all we have to do is, so now that we know their work efficiency and how much this part is, we can just divide the sum of these work efficiencies from 3/8. Let's figure that out. So 3/8 divided by the sum of 1/20 plus 1/16, simplify, and then you would get 10 over 3. So 10 over 3, or we could even write it as 3 days and 1/3 of one more day. So there, that's done, and the answer would be 3 and 1/3 hours. If I was saying days before, I'm sorry, the unit is hours. That answer you answered it earlier on. So that was our answer. Do you have any other more solutions? Or did you get it wrong? Well, take a look at our solution back up here. And then you can see every single step, and you might want to re-review it all over again by yourself. So the main goal of this video was to see how visualizers, like for example, drawing a number line, could help you visualize what's going on in the problem, and see how this just made it super easy for us to calculate out the answer. Thanks for watching this video, and we'll see you next time. If you haven't checked out our playlist yet, I would super recommend you to do it. The link will just be in the descriptions down below, and I hope you have a good day. See you next time.